Hello, my name is Alexander Scheffler and this is joint work with my advisor Steffen Bondorf. We are both from the Ruhr University Bochum in Germany. This is a brief teaser and the title of our paper is Network Calculus for Bounding Delays and Feed-Forward Networks of FIFO Queuing Systems. Deterministic network calculus, or short DNC, is a theory of deterministic queuing behavior that is able to derive worst-case bounds such as end-to-end delay of a data flow. Its general challenge is to derive bounds that are close to the realistic worst case. The objective of our approach is to deliver a scalable FIFO-aware analysis for feed-forward networks and its tool support. The challenge that we tackle in this paper is to adapt a backtracking scheme to derive arrival bounds to the FIFO analysis where there are certain peculiarities to consider to derive best possible bounds. We have implemented our approach into the open source deterministic network calculator tool. We combine a previously published backtracking scheme for arrival bounding and the so-called least upper delay bound. We can mention that our new approach, LUDBFF, almost always beats SFA FIFO by a margin of up to 75%. Deborah integration, an alternative that does not go into the very details, led to uncompetitive results. TMA, developed for arbitrary multiplexing, is worse than SFA FIFO since it doesn't make use of the FIFO property. More details are in the long conference video and in the paper. Get in touch if you have questions.
Hi everyone, my name is Mariam Akbari Moqaddam. In this teaser, I'm going to introduce SDH, size estimate hedging for single server queues. In a single server queue where only one job at a time can be processed, shortest remaining processing time or SRPT policy is optimally minimizing the mean sojourn time in the system, which is the expected amount of time that a job needs to wait in the system before being completed. However, in practical settings, job processing time might not always be known before scheduling, but instead, estimated processing times of the jobs can be used. We are using a multiplicative error model to generate the estimated processing times of the jobs. This is done by multiplying the job processing time by the job processing time estimation error. We introduced size estimate hedging or SDH policy, which is an index policy that combines two scheduling policies, shortest estimated remaining processing time and shortest estimated processing time. It does not need to know any information about the jobs other than their estimated processing times for scheduling. It uses SCRPT until the point that we know a job is underestimated. At that point, the index of the job is frozen, but instead of switching to SCPT, we give credit for the job's cumulative elapsed processing times. We also provide numerical results and show that SDH works well as long as there is no variance in the estimation error distribution. Thank you.
Spot instances are cheap but unreliable and may be revoked anytime by the cloud provider. Because of that, users of data analytics applications are reluctant to using the spot market for MapReduce or Spark applications. In this talk, I'll show how we built a high accuracy performance predictor that can help users understand their expected level of performance as a function of bit. Join our talk to discover how we achieved this.